5.7 rates of change in slope. When we're doing the rates of change or the slope of something, our change is the change in y over the change in x, or your change of your dependent over the change of your independent. If we look at our first set of examples here, it tells us to find the rate of change by using the change in postage over the change in year for each time period using the table. So it first asks us from 2003 to 2004. So the cost from 2003 to 2004 is from 37 to 37. So we can say that the change in the postage is 37 minus 37, and the change in the year is 4 minus 3. The 37 minus 37 is 0, and 0 over anything is 0. So that change there is 0. From 2004 to 2006, we have from 39 and 37, and then the 6 and the 4. So 39 minus 37 is 2, and 6 minus 4 is 2, so that's equal to 1. From 2006 to 2008, we have 42 and 39, so that's going to be 42 minus 39, and then from 2008 to 2006 is 8 minus 6. So the 42 minus 39 is 3, and then the 2 years is 3 over 2, so that's also 1.5. With your slopes or your rates of change, you're going to keep these all as improper fractions as well. From 2008 to 2013, you have from 46 to 42, so that's going to be 46 minus 42, and then 13 minus 8. 46 minus 42 is 4, and the 13 minus 8 is 5. So this is also 0.8 or 80 cents per year. When you look at these, there's not a constant rate of change here, so this would not be a linear function. If we look at the next example, F, it says label the vertical increase, the rise, and the horizontal increase, which is the run, between points 4.37 and 6.39 to find the rate of change or rise over run. So when you do this, you're going to do the 39 minus 37, and then you're going to have the 6 and the 4. So 6 minus 4. The 39 minus 37 is 2, and the 6 minus 4 is 2, which is equal to 1. So 1 cent per year. For G, we have 639 and 842, so we're going to do 42 minus 39 and 8 minus 6. The 42 minus 39 is 3, and the 8 minus 6 is 2, which is also 1.5. So 1.5. For H, we would have the 2 points, 842 and 1346. So we're going to have 32 minus 46, and then 8 minus 13. You could do these the other way as well, to where, you have 46 minus 32 and 13 minus 8. Okay, so when we do this, we're going to get 4 over 5, which is also 0.8. For our next set of examples, we're using tables to find the slopes. We can do this one of two ways. We can use our slope formula, which is the change in y over the change in x, or we can use it by looking at the graph and saying to ourselves, okay, we're going from one point to the next. We're going to go up we're going up 1 here, and then we're going to the right. Oh no, we got to look at those values. This is going to be 1, 2, 3. So we're going up 3, and then to the right 1. So your slope here would be 3. Your slope is represented with the variable m, so this would be 3. You can also, like I said, use your 2 points. If we use your 2 points, you can do 4 minus 1 over 3 minus 2, and that's going to be 3 over 1, or just 3. For B, we are going, this is negative 2, so we're going to the left 2 and 2 up 3. So rise over run, we're going up, or really we're going down. let's do this. We're always going to do this to the right. So we're going to go down first. That's going down 3, and then to the right, we said 2. So that's going to be negative 3 over 2. Again, we can use those points as well. We have negative 2, 3, and 1, 0. So this is going to be 3 minus 0 over negative 2 minus 1. The 3 minus 0 is 3, and then the negative 2 minus 1, minus 1 is negative 3. So this is going to be negative 1. Why was this different? Down 3, to the right 2. Oh, no, yeah. So if we look at this, we go back and look at this. This 2 should have been a 3 here, because I did not pay attention that you're over here. So this would be 1. So it's going to the right 3. We got to make sure we pay attention to that. For C, we have the 2 points 0, negative 3, and 5, 3. So we're going to go left to right. We're going to go up. This is 1, 2, 3, 4, 5, 6. And then we're going to go to the right. 1, 2, 3, 4, 5. So this is going to be up 6, right 5. So 6/5. We can also use our 2 points. If we did that, we would have 3 minus negative 3 over 5 minus 0. Add the 3's. This gives us 6, and the 5 minus 0 is 5. So 6 over 5. For D, again, we can use those 2 points. If we did that, we are going down and to the right, so this is going to be negative. We're going to have negative 3 minus 2 over negative 2 minus negative 3. So negative 3 minus 2 is negative 5. Add the negative 2 and the 3. It gives us 1. So this is just negative 5. For our next examples, we are finding the slope of each line that passes through the given points and using the slope formula. So if we look at example A, we have these 2 points. We can use our slope formula. We're going to have the change in y over the change in x. So your y values, you can start with negative 1 minus 3. And then because you got the negative 1 first, you're going to use the x value from that point first as well. So that's negative 2 minus 2. Negative 1 minus 3 is negative 4. And negative 2 minus 2 is negative 4. These are both positive now, and this becomes 1. For B, we have an x value of 3. We're going to use 3, 2 as x1, y1, and 3, 4 as x2, y2. All right, so we are going to be doing 4 minus 2 over 3 minus 3. 4 minus 2 is 2. 3 minus 3 is 0. Anything with 0 in the denominator is undefined. For C, we have our 2 points, so we're going to do negative 5 minus 9 over 2 minus negative 1. Negative 5 minus 9 is negative 14. Negative 2 plus 1 is 3. So that's just going to be 14, negative 14 over 3. With these, we also are describing if the slope is positive or negative, 0 or undefined. So A was positive slope, and then C is a negative slope. For D, we can use x1, y1 as 1, 5, and x2, y2 is 2, 5. So we're going to have 5 minus 5 over 2 minus 1. 5 minus 5 is 0, 2 minus 1 is 1, and that would be 0, so this would be a 0 slope. For our next examples, we're finding and interpreting the slope for each real-world situation. So we're just going to use the graph here to find our slope. So remember, our slope is found by changing the change in our x value. So we can do 150 minus 180 over the change in our y value. So it would be 50 minus, or the x value, sorry, 50 minus 20. So this is going to be negative 30 over 30. Those zeros cancel out. Negative 3 over 3 is negative 1. So slope is negative 1. For B, we have the 2 points 30, 15, and 40, 25. 30, 15, 40, 25. So this, I'm going to use my slope as 25 minus 15 over 40 minus 30. 25 minus 15 is 10. 40 minus 30 is 10. So your slope, again, is 1. For C, we're going to use 2 points again. So our slope is going to equal the 10 minus 25 over 50 minus 77. The 10 minus 25 is going to give us 15, or the negative 15. And the 50 minus 77 is going to give us negative 27. They are both going to become positive. They're both divisible by 3. So this is going to become a 5. This will become a 9. So our slope is 5 over 9. For our next one, we're using these 2 points. So we're going to do 4,000 minus 3,000 all over 60 minus 40. So m is equal to 1,000 over 20. We're going to get rid of those zeros, and 2 goes into 150 times, so slope is 50.